Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about ratio, proportion, and prorating. Let's start with ratios. A ratio is a comparison of two or more quantities. You can write a ratio in ratio form or in fraction form. You can write it either with the colon or as a fraction. If it's more than two numbers, then leave it in ratio form like that. The order in which you write the ratio is very important. It's not necessarily smaller number to larger number or vice versa. It is what quantity is being compared to what quantity. And the numbers should be in that ratio. The other thing that's very important is that the quantities that are being compared must be in the same unit. So for example, if I was comparing two lengths, and the one length was 1 meter and the other length was 50 centimeters, I'm either going to have to change this to centimeters so that they're both in centimeters, or this to meters so that they're both in meters. I'm going to avoid decimals, so I'm going to change this to centimeters. 1 meter is 100 centimeters. And then once your two quantities are in the same unit, you can drop the units. So we would say the ratio of this length to this length is 100 to 50. And the other thing that you want to do when you're working with ratios is you want to reduce them. Ratios can be written as fractions. So for example, 100 to 50, I could write as 100 over 50. And the way I reduce fractions is I look to see what number divides evenly into both the numerator and the denominator, and I try to look for the largest number. So in this case, I can divide 50 into the numerator and the denominator. So when I divide the numerator by 50, I get 2. When I divide the denominator by 50, I get 1. We can do the same thing with ratios in this form. I can divide both of these numbers by 50 to get a ratio of 2 to 1. Just like you always want to simplify fractions, you always want to simplify ratios. So let's do some examples of ratios involving fractions and decimals as well as whole numbers. If you're more comfortable writing this in fraction form to reduce, that's fine. The largest number that divides into both the numerator and the denominator would be 2. So I divide the numerator by 2. I divide the denominator by 2. Or you can leave it in ratio form, divide each of these numbers by 2. You often see decimals in your ratios, and in order to simplify this, I'm going to get rid of my decimal point. Now, I have 2 digits after my decimal point here, so if I multiply this by 100, I'll move my decimal point 2 places and it will be gone. If I multiply this by 100, I also have to multiply this by 100. So I'm going to multiply both numbers by 100. Now I'm going to reduce. I'm going to look for the largest number that divides evenly into both of those. The largest number that divides evenly into both of those numbers is 25. So I'm going to divide this by 25 to get 10. And I'm going to divide this by 25 to get 43. So that ratio would reduce to 10 to 43. And that's going to be a little bit easier to work with than 2.5 to 10.75. If you have fractions in your ratio, you have two options. Because in this example, both of these fractions convert to easy decimals, I'm going to do that. So 1 1/2 is 1.5. 4 3/4 is 4.75. Now I'm going to deal with this ratio the same way I did with this one. I'm going to multiply both sides by 100. Again, the largest number that divides evenly into both of these numbers is 25. So when I divide this by 25, I get 6. When I divide this by 25, I get 19. Can't be reduced any further, so that's our ratio. In this example, our fractions don't convert to nice even terminating decimals. So in this case, I'm going to keep them in fraction form, and I'm going to look for the lowest common denominator. So that's the number that both 3 and 12 divide into, and that number is 12. So what I'm going to do is I'm going to multiply this fraction by 12 and this fraction by 12, and that will eliminate my denominators. So when I multiply this by 12, I'm going to get 12 over 3. When I multiply this by 12, I'm going to get 12 over 12. 12 divided by 3 is 4. 12 divided by 12 is 1. So this ratio would simplify to 4 to 1. In our next example, we have mixed numbers, so we have a whole number combined with the fraction. And before we start multiplying by anything, we need to change these to improper fractions. So 4 1/3, I go 4 times the denominator of 3 and add a 1. So that's going to be equivalent to 13/3. To change this to an improper fraction, I multiply 2 times 2 to get 4 plus 1. That will be 5/2. Now that we have improper fractions, we can multiply by our lowest common denominator. So I'm looking for the lowest number that both 3 and 2 divide into, and that number would be 6. So I'm going to multiply this side by 6 and this side by 6. When I do that, the 3 will cancel, so I will get 26. When I do the right-hand side, the 2 will cancel, and I will get 15. So this ratio would simplify to be 26/15. Sometimes in business, you might be asked to convert your ratio to an equivalent ratio where the smallest number is 1. So in this case, our smallest number is the first number, it's a 2. So instead of writing this as 2 to 3, they want it written 1 to something. And when you do that, you're going to introduce decimals. The way that you do that is you divide both of these numbers by 2. So 2 divided by 2 is 1. 3 divided by 2 is 1.5. So 2 to 3 can also be written as 1 to 1.5. In the next example, our smallest number is the second number. So that's the number that we want to change to a 1. How do we change a 3 to a 1? We divide by 3. If we divide this number by 3, we divide this number by 3. So 4 divided by 3 will be 1.33, rounded off to 2 decimal places. 3 divided by 3 is 1. So it's not necessarily the first number or the second number that you're reducing to a 1, it's the smallest number. Next thing I want to talk about is proportion, which is a statement of equality between two ratios. And you'll find the idea of proportion very useful in business and a lot of other real-life applications. So for example, you might see something like this. You've got one ratio in fraction form equal to another ratio in fraction form, but one of the values in one of the fractions is unknown. So in order to solve this, I use a process called cross-multiplying. You go across the diagonal and multiply those two numbers. So 10 times x will equal, go across the other diagonal, 13 times 20. In order to solve for x, we're going to divide both sides by 10. So we're going to take 13 times 20 divided by 10. And that value is 26. And if you understand the idea of cross-multiplying, you might be able to take a bit of a shortcut and realize that the two numbers that are across from each other get multiplied, and then that product gets divided by the number that's diagonal to your unknown. With proportion, you're probably going to see the question in a word problem. So let's take a look at a few examples. So this example says a profit of $2,000 is realized when 75 items are sold. What is the expected profit if 500 items are sold? We know that this is a direct proportion. If we were to double the quantity of products sold, we would expect to double the profit. So as one value increases by a certain factor, so does the other value. Similarly, if we sold half the number of items, we would expect half the profit. So if the quantity is reduced by a certain factor, we expect the other quantity to be reduced by that same factor. So when you set it up, it really doesn't matter the order that you put the two numbers on one side of the proportion, but it has to be exactly the same order on the other side. In this case, it makes more sense to put profit over the number of items sold, which is how I'm going to do it. But if we flipped it, that would be fine as long as it was flipped on the other side. So I'm going to put profit divided by the number of items, 75, will equal, so if profit is in the numerator on this side, profit has to be on the numerator on this side. We're trying to find the expected profit, so that's our variable. Over number of items sold is 500. So what I was saying is if I had put the number of items over the profit, that's fine. Then I would just put number of items over profit on the other side. Mathematically, it's the same. Again, to solve this, I'm going to cross multiply. So 75 times x will equal 2,000 times 500. To solve for x, I'm going to divide both sides by 75. So in other words, I went 2,000 times 500, those are the two numbers across from each other, divide by 75, the number that's diagonal with your unknown. And our answer is $13,333.33. Our next example has the ratio given, but it's a ratio of three things. It says concrete is a mixture of cement, sand, and gravel in the ratio 1 to 2 to 4. What that means, because the question says cement, sand, and gravel, then we assume this is cement, sand, and gravel. So every 1 part of cement, we would have 2 parts of sand and 4 parts gravel. Then we're told that 10 kilograms of sand is available, and we want to know how much cement would we use and how much gravel would we use with that 10 kilograms of sand. I think the easiest way to solve this is to split this up into 2 separate questions and calculate cement separate from gravel by using 2 different proportions. So the thing that I know is sand. And so if I'm talking about the ratio of cement to sand would be a ratio of 1 to 2. Remember, it's cement to sand. So if I look at how much sand is available, 10 kilograms, that needs to go in the denominator because it's cement to sand. The amount of cement I want to find is unknown. I'm going to cross multiply. So 2 times x will equal 1 times 10. Divide both sides by 2, and I would need 5 kilograms of cement. Then in order to calculate how much gravel is needed, I would do the same thing, but I would just focus on this part of the proportion. I need 2 parts of sand to 4 parts of gravel. So this is sand now to gravel, and I'm given the quantity of sand, so 10 kilograms. I want to know how many kilograms of gravel. I cross multiply to get 2 times y equals 4 times 10. Now I divide both sides by 2. And I would need 20 kilograms of gravel. Let's take a look and just see if our quantities, when I put them in ratio form, if they would reduce to this ratio. So the amount of cement comes first is 5 kilograms. My second number in the ratio is 10. And the amount of gravel, third number in the ratio, is 20. Does this reduce to 1 to 2 to 4? Well, let's look for the largest number that divides evenly into all 3 numbers, and that number would be 5. When we divide 5 by 5, we get a 1. When we divide 10 by 5, we get 2. And when we divide 20 by 5, we get 4. So it does reduce to the correct ratio. However, my method might look a little bit different than what you might see in your textbook. Now let's talk about prorating. The process of prorating is taking a total quantity and allocating or distributing it proportionally. And often that's going to be dependent on time. So for example, if we know the annual fee for vehicle plates is $1,450 and we only want to register the vehicle for 5 months, what is the prorated fee? There's different ways that we can calculate this. You could set it up as a proportion. So in this example, we could set the price of $1,450 is what we'd pay for 12 months. And we want to know what would we pay for 5 months. So the fee over the number of months equals fee over number of months. We cross multiply to get 12x equals 1450 times 5, and then divide both sides by 12 to get $604.17. Another way that I could have solved this is I could have taken the yearly fee and just multiplied by the fraction of the year that I need this. So because there's 12 months in a year, I only need for 5, I'm going to multiply by 5 over 12, and I would get the same value. Often in doing these questions, there's more than one way to approach it, and either option would be fine. Let's take a look at some other types of prorating questions you might encounter. Our next example says a $1 million lottery ticket is to be divided between Jim and Bill in the ratio 4-to-1. How much does each person receive? And the biggest mistake I see students make with this type of question is they just take the total and divide by 4. What you have to understand is that there are actually 5 parts altogether. Jim's going to get 4 parts of the total, and Bill's going to get 1 part of the total. So what you need to do is add these two numbers to get the total number of parts. Now we're going to calculate Jim's portion and Bill's portion separately. Just like with the last example, there's two ways we can approach it. We could set it up as a proportion, and in order to do that, we could put the amount of money, so $1 million, that's the total amount of money, so that should be over the total number of parts, which is 5. And we want to know Jim's amount, so we'll put a J there, and he gets 4 parts. So now we cross multiply, so 5 times J will equal 4 million. So Jim should receive 4 million divided by 5 would be 800,000. The other way I could have solved this is I could have just taken the $1 million and multiplied by the fraction 4 over 5, because Jim is going to receive 4/5 of the total, and that will give me the same value of 800,000. Once we know Jim's amount, we can just subtract that from the total to get Bill's part, or we could also set up a proportion. The total amount of money divided by the total amount of parts will equal the amount of money Bill receives because he has 1 part. So we'll get $1 million divided by 5 is 200,000. Or the other option is I could have just taken $1 million and multiplied by 1/5. My approach on this type of question might be different from your business text, so it's up to you to choose what makes the most sense to you or what's easiest. Let's do one more example. The next example says 2 business partners invest in a business. Betty invests $25,000 and Anne invests $35,000. How should they fairly divide a profit of $150,000? Well, we know that they should split the profit in the same ratio that they invested. So the ratio that they invested was 25,000 to 35,000. What I'm going to do is reduce this ratio before I even start. So I'm going to divide both sides by 5,000, and I get 5 to 7. So the profit should also be split in a ratio of 5 to 7. So just like with the last example, because I'm told the total profit, I need to find the total number of parts. I have 5 parts and 7 parts, so the total number of parts is 12. Now I'm going to calculate how much each person should get. Let's start with Betty. So we have a total profit of 150,000, and we have a total number of parts, 12. I want to know what portion or amount Betty should get, so I'm going to call that B, when Betty gets 5 parts out of the total. Or in other words, you could take 150,000 and simply multiply by 5/12. And we get B equals 62,500. We can either subtract this from our total to get Anne's share, or we can set up the same type of proportion. So the total amount of money over the total number of parts will equal Anne's portion of the money over Anne's number of parts. Cross multiply, 12A is equal to 150,000 times 7. Divide both sides by 12. So 150,000 times 7 divided by 12 is 87,500. We could do a check by adding these two up to make sure that they equal 150,000. You could also do a check to make sure the ratio of this number to this number is 5 to 7. Again, my approach might be different than what your business text shows, so it's a matter of you deciding what method makes the most sense to you or which method you prefer.